The event today is called Life as an Engineer, or Life of an Engineer. I can't remember I think we've called it in different names in different places. But the main point of today is to try and convey a sense of what it will be like once you graduate and you go into your jobs as engineers, if that's what you'd like to do. Kind of move away from some of the university side of things, which is a lot more academic, a lot more about the technical details, or kind of even some about the project managed stuff. We kind of touched on it a little bit, but I don't think it really gives you a nice idea of what it will be like once you get into industry. What can you expect from the skills that you'll be required to have, as well as just kind of perhaps what some of the culture's like. So we've invited 4 guests today. They're all from companies that have a presence in the region, as well as some that are also multinational companies, I believe. So they'll all be really good for giving you an insight as to kind of what it will be like. We've got people from different stages of their career as engineers, so it'll be really good to kind of get an insight of what it will be as you move through. We'll go through each speaker, let them have a chance to speak, and then at the end we'll kind of do a panel style Q&A if you have any questions. Thank you all for coming. There will be a recording available at the end as well if you want to kind of refer back to anything like that. So I'm going to invite up our speakers from AGH to come and give us their experience. Thank you very much.
Good afternoon all. Myself is called Zach, and this is Jordan from AGH Engineering. We're a local firm in York which we focus on both mechanical and electrical engineering. We provide most of our designs and electrical designs and mechanical, that is, to our main client, which is Network Rail. We also deal with other companies such as Siemens, Amco, Giffen, Balfour Beatty, companies like that, as well as many more. There's a little bit about our company there and what we focus on and what we do, from electrical engineering through surveys, detailed design and assessments and such as things like that. Our website is also on the bottom of this, so if you want to look at it any more, we can also do that. That's a little bit about AGH.
So a bit about who we are. So I'm Jordan Benjamin Sutton. I'm a project manager at AGH Engineering. I'm responsible for day-to-day management and leadership of projects, including things such as tracking costs and budgets of the projects, providing clients with regular program updates, providing narratives on scheme progress and updates. Aside from my job, I'm qualified as a Prince 2 practitioner, and I'm a member of the Association for Project Management, working towards my chartership.
Yeah, and my current role is electrical design engineer, responsible for the delivery of compliant detailed designs, which include the following things: of detailed site surveys, reports, specifications, CAD design, which is our main output from what we do, electrical calculations, but also mechanical as well. Currently qualified as an engineering technician through IET, which is the EngTech, and technician member of the IET as well, working towards chartership. We'll go into that a little bit more as well through the different levels you can reach with them.
So my route into engineering, so I joined the company straight out of GCSEs in 2015 as a junior design technician apprentice. I got put through college, did an NVQ in electrical and electronic engineering at York College, finishing that in 2018. 2019, I decided I'd prefer a more management style role, so rather than continue as an engineer, I transitioned into a junior project manager. From that point, I became a member of the APM and began my journey to chartership with them, and I progressed through the roles at AGH, so most recently becoming a project manager last year.
Yeah, my journey started a little bit similar to Jordan. So 2018, undertook GCSEs and then joined the company as a junior design technician apprentice. Undertook my level 3 BTEC NVQ, a diploma through York College, which was with AGH. I then started the IET career path through engineering technician, EngTech status, and currently working towards the iEng, which I've nearly completed, and then finally it is the chartership registration CEng, which I'll be looking to get. Whilst in AGH, they put you through multiple different courses, specifically us, which is rail. So there's things like City and Guilds courses, 2391, which is a test and inspection specifically, and things like level C, which do with substations and HV. So that's things that once you're out in that industry, they will fund for you to go and be put through. While I was at AGH, they're sort of the four positions I've gone through at the minute, currently holding design engineer, hoping to go to senior shortly, and then you'd push on to go to lead senior and eventually principal, wherever that might be. The other routes we do have, not the route I took, but for more, obviously guys that you might be looking to do in the future, is we have currently 2 people who are year in industry, so they've come with us to take a year out, get a feel for what we do day to day, get a bit of experience, see if it's for them, see if it's for not, hopefully take something away from it no matter what. Or obviously we have the graduate design technicians / engineers that might join us full time if that's something they'd like to do.
We also have our IET accredited professional development scheme, which we were awarded recently. So we've got a lot of presentations for that particular scheme. It's very successful. 60% of our engineers achieved the professional registration as part of the scheme, which is higher than the 16% average for schemes of a similar size.
Yeah, so sort of just building on what Jordan said there, it's where you'd come in with us straight away. AGHE, for us personally, and I don't know if it's like this for other companies, they'll fund your IET sponsorship and everything like that, and they have a accredited scheme which gets you into that Eng Tech status, builds onto iEng, and then they'll push on to finally chartership if that's where you want to get to.
Working in engineering, so for myself as an apprentice engineer, when I started out I undertook several different projects. An example project for me was I undertook 2 designs for LED handrail renewals at 2 footbridges in Lincoln, which I enjoyed doing that project as an apprentice. It was quite a good one, doing lots of design drawings and electrical calculations and models. I found it useful spending the first few years of my career as an engineer, which meant the transition to project manager. I already had a bit of grounding, a bit of technical knowledge that I could transfer to my new role. But now as a project manager, I oversee multiple projects rather than producing the deliverables themselves. I enjoy the process of seeing a project through its entire life cycle, which is seeing it from the pricing stage all the way through to design and then installation of the project or scheme at the end.
Yeah, so these next 3 slides are sort of a day-to-day. It's something that I do, starting from a project, seeing it through sort of to the end. So something we always start with surveys. Engineers try to go out to site, undertake a detailed survey, which then provides the essential information to get back into our design when we're back based in the office. Undertaking the surveys, it allows you to basically work away in numerous places around the UK. From example, I've worked from Inverness, down to Portsmouth. As a design engineer, they're the sort of things I've worked on so far, and then the bottom 4 photos are just examples of where you can work and sort of on track and type of things you might see when you're undertaking them surveys. The next one is when you're back in the office, you're actually undertaking them designs. So in the bottom right, you'll see this is basically what's called the GRIP process. It's our network rail design. Basically, how we get involved with the network rail design process. So it comes in at option 1, which is basically the idea. You'll go through to option 2, is it feasible? Is it worth the money? And then through 3 to 8 there. We focus on 3 to 6, which is the option of the design. Is it feasible? Can we do it? 4 and 5 is the detailed element, and then 6 would be commissioning, and then 7 and 8 is more the network rail process of handing back. And then the bullet points there of just 1 and 2 is sort of what we would do in that formal design process, undertaking IDCs, presenting your drawings to the clients, and then you push on to the formal design / the AFC, which is approved construction. This is where you update your design to the comments and you produce that to the RAM, which is an asset owner basically in the rail, and he'll sign that off and say he's happy, which will then become his asset and handed back to Network Rail overall. Final one is just some positive I've found with working in rail engineering. It's a stable career due to government funding, control period 7, which is how they differentiate their money between each year. It's had a £44 billion spend, so you know you're in a stable career. You're not like oil and gas at the minute or anything like that. You know, you're continuously pushing towards sustainability and green renewables, and it's constantly putting back into that economy and trains are running. Witnessing electrical designs progressing from drawings to operational equipment. So the drawing on the left hand side is what is physically represented on the right. So that's something I designed, and then you obviously see it in physical format once it's been installed. And the final one is multiple career pathways. A bit like George straight away said, he started as electrical engineer, but you can push to project management quite easily. Or you could start in, for me, electrical and move to civils. It's not just a one career sort of pathway. You can sort of start somewhere and easily jump to different sort of elements and disciplines within that.
Some important advice, a couple that we've picked out. So focus on communication, not as much as technical skills. Don't be afraid to ask questions. I think that's quite a big one for us as you come in as a graduate. Asking all the right questions to get you through the design stage, asking them as you have them rather than leaving them till the end can cause a couple of issues. So asking questions, very important. If you don't feel you're ready, that's not to worry. You'll learn most of the skills while progressing your career. And then remembering to continue professional development, so for the IET, the APM, or any further qualifications that you might need for your career. That's it for us.
Yeah, there was any questions, but I think we're just going to take a panel at the end.
Yeah.
I think for all of us for that. So if there's any questions, feel free to save them till the end, and we'll answer them then.
Thank you.
Senior software engineer now at Hitachi Rail. So what I wanted to do, I just wanted to give you a kind of my route into engineering, which started here at the University of York. I did electronic engineering. When did I graduate? Back in 2004 I graduated. Then I didn't really know what I wanted to do in my final year, and then sort of during my final year project, my lecturer, he offered me a PhD that was sponsored by Nestle Product Technology Centre. So Nestle factory just down the road, the Product Technology Centre there is the fancy new building. So my PhD was measuring Kit Kat wafers. So I'd done a bit of kind of coding, the odd module, bit of, I don't know if anyone does kind of software here, but learning C, some sort of hardware languages like VHDL and stuff. Quite enjoyed them. Didn't really sort of appreciate software engineering or anything really as a career, but doing this PhD kind of had to get really involved that side of thing. So yeah, I'll just explain the kind of project. So this diagram here, kind of Kit Kat wafers moving along a conveyor belt. So the idea was to measure kind of volumetric measurements. So we decided we'd profile them using lasers. So we had 2 lasers, 2 cameras, looking at different viewpoints. The wafer there, as it moved along, as the wafers move along the conveyor belt, they go through the laser lines. Cameras, you can see there, as they move through, the kind of shape of the laser line changes. If you watch that laser line with a camera, you can start to make calculations on height, width, you track edges, you can get the angle it's coming through, you can measure the length of the wafers, that kind of thing. So the idea basically was that Nestle wanted to kick out any wafers that were too small. The chocolate's very expensive, wafers are very cheap. If there's any damage to the wafer, they can kick it out, mash it back up, make new wafers, but chocolate's very expensive, so any wasted chocolate's big money to them. So I think there were sort of nearly 4,000 wafers coming through a minute on this conveyor belt that needed. So the target was to be able to detect a fault with 0.1 of a gram of chocolate. They wanted to sort of reject on that. So that was, sort of kind of bit self-taught software engineering. Guys in my lab knew a lot more than me. So when you're pressed to do something, that's when you get learning, yourself, and kind of actually I quite enjoyed software. So finished, graduated, got my PhD, looking for a job, found one in York. I don't know if anyone has heard of Vickers Instruments, very old company in York. There's a little cabinet in the electronics building there. It's a sort of famous old company, lots of optical equipment. They've got a little stand over in the electronics building. So it was the company who used to be Vickers, had been bought by an American company called Nanometrics. So I went there as a metrology sort of software engineer. Didn't know anything about what they did really. It turns out they were in semiconductor. So it was all semiconductor process technology. I was there, unfortunately, so this was 2008. I think I got one pay slip and then I got made redundant. So the dot-com crash and sort of American company, like, you're gone. So, try again. Ended up moving down south, heaven forbid. So a company called Instron. Will this play a video? That should be an embedded video there. I don't know if that'll play on.
You can try, but I don't know anything deeper.
No, oh, okay. So this company, they made material testing machines. Basically machines that would pull apart materials or compress them, get all the metrics of breaking points, compression, did things like machines that tested sort of heart stents and things like that for continuously compressing them. So I was an embedded software engineer there. So that kind of means software that's not running on a typical desktop PC or in the cloud. It's a kind of on a dedicated CPU for these machines. So there I was there as a junior engineer, learnt about kind of the software process, so developing requirements, then implementation stages, getting that signed off, design before that, getting that signed off, then implementation, testing. So this kind of process was really ingrained in their culture. I sort of knew nothing about that for university, but I was there for 2 years. So I want to come back to York, and I actually got offered my old job at Nanometrics back. So, so just to kind of show you, there's a couple of images here. So you got like a silicon wafer there with all the chips or memory, whatever, printed on there. Really high powered microscopes on there. So different, so you get lots of different powered microscopes that sort of automatically come round when you needed them. So they were the wafer would sit on a stage. They called it the XY stage. So this thing could move like nanometers at a time. Incredibly expensive machinery. Yeah. So that'd sit on this huge block of granite. So this is a couple of meters wide. Because the amount of G-force this XY stage would generate was something, because it moved so fast. Tiny little movements, but it moved so fast. Then we had the microscopes would be moved by a Z stage. It was again incredibly accurate. Again, sort of nanometers movement there. So the idea, what sort of we made in York were called overlay analysis tools. So when wafers are being produced, they're made in layers, and what overlay does is measure the distance, or basically the offset between these layers, so making sure you've got them lined up so you can kind of see through each layer, so you get these targets printed on. So these different targets here, they're kind of showing shapes from different layers of the wafer, and then basically you would measure the point of symmetry for each layer, and then you'd measure kind of offsets there, and that'd be your how well lined up your wafers basically. So these diagrams, they're about, I think these targets, they're sort of about 25 microns across. Yeah, 25 microns square, so give you some idea of the kind of the sizes that we're looking at. We measure the kind of target is all sub-nanometer precision on your alignment measurements, and he just wanted to do it as fast as possible. So much of the we called it a MAM time, so move, acquire, measure. So you'd move the stage to get to these targets. There'd be a certain time to acquire these images. Your camera would have to get to focus, take the images, and then you'd measure. So the constant pressure was, can we get MAM time, they called it, can we get that down, and can we make it as precise as possible? So I was kind of a junior engineer here. There was virtually no process at this place. It was sit down, code. There's a team of you. There's hardly any testing. It was kind of get it on the machine. Does it work? Keep hammering it. Does it work? I'm not saying this is the right way to go. This is what it was like at this company, and I've worked, different places that it's kind of a lot more relaxed like this. It seemed to work. We did very well. Sort of MAM time came, very good. Got to travel, lots of travel to Korea, companies like Samsung, west coast of America. Spent quite a few trips to Silicon Valley and stuff. So as a young engineer, it was brilliant. Absolutely loved it. But unfortunately, I was never too far from redundancy. There, and 5 years I was there, and they closed the York office. So made redundant. Onwards over the river. Sterling's in here today, so Omnicom, one of Sterling's company, a rail company who kind of similar machine vision orientated, lots of software. So went there for an interview. Turned out they had a profile system using the same cameras as what I'd used during my PhD, which made the interview quite easy. So yeah, I got taken on there. I've been at the same company. We've been bought out a few times, and say now we're Hitachi Rail. I've been there for kind of 14 years now. Gradually progressed to a senior engineer. So what kind of things we do? That's just a real sort of quick show. We call it infrastructure monitoring on rail. Basically, a lot of my work is sensors strapped to underneath the train. So train these, we have there's a fleet of train that Network Rail use for infrastructure monitoring. So these trains have our systems on. One of them, such systems, this line scan system, we call this. 7 cameras across the full width of the rail. So you've got 3 cameras looking at each rail, 1 looking in the middle. We get a line of an image every it's less than a millimetre, about 0.7 millimetre. So these things can go, obviously, at sort of 125 miles an hour. We get images like this, so recording sort of hundreds of miles worth of data, sort of one basically long image that's just gradually built up. And then these images are processed, deep learning models run on them now. So AI stuff, they're looking for faults along the rail, so or identifying assets such as clamps. You can see a clamp in that image on the rail there, any cracks in the rail, any missing fasteners, that kind of thing. This is all done now by, say, deep learning models. We're doing that live now on the vehicle, so as images are being recorded, they're being analysed on vehicle, any results shipped off the vehicle into the cloud. So it's real sort of fast moving, trying to keep up with advances in AI, that kind of thing. So day to day, I guess majority of my work being a software engineer is coding, but there's quite a lot more to it. I guess there's lots of meetings with customers for figuring out requirements, and then kind of taking a systems kind of putting your systems hat on, how is this actually going to work on a train? You know, things like power requirements, going to get that from the train. What else does this system need to interface with? Universal power supplies, positioning. Any faults you find need to be very accurately positioned so they can go and find them on the railway. So you've got lots of GPS systems, tachometers, just lots of different things to think about when you're a software engineer. It's not just coding, it's stuff. So what do I do day to day? I guess work in a small team, all software engineers in our team, kind of working on different projects sometimes, or working on one project at other times. So I don't know if there's any software engineers in here, but kind of agile workflows. So you have a scrum, decide what you're going to do, you go and do it, you pick up kind of bug tickets, fix them. There's a testing team, they'll test your tickets, feed back to you, go and fix it again, that kind of thing. I think that's about it from me. I'll take any questions at the end if. Yeah, thank you.
Thank you for all of our speakers. I do just want to point out that I think most of you only had about 3 days, I think, to pull together this presentation for us today. So really, really grateful for all of you last minute. It was really, really interesting, all of you listening to your different experiences and stuff. So thank you for putting around that last minute.